Floods, fires, epic drought. The most recent climate report issued a code red for humanity when it comes to climate change. The alarming news from the Intergovernmental Panel on Climate Change has sounded alarm bells. I'm USA Today's Ralph Villaversa, and this is Code Red for Humanity, a look at climate change and extreme weather across the world. The new climate report has people asking a number of questions. For example, moving forward, will I be able to live in a certain part of the US or not? Here's another one. Will insurance cover my home due to floods or hurricanes if I'm in a certain part of the country? We'll attempt to answer some of those questions coming up. But first, we begin out west, where they're experiencing a drought that they haven't experienced perhaps ever. And as you're about to find out, this epic drought is affecting more than just crops and yards.
The southwestern United States is experiencing a drought of epic proportions. Reservoirs are running low, crops are thirsty, and raging wildfires have become the norm. Here's how a mega drought happens and why parts of the country are so vulnerable. A drought is defined as a deficit of precipitation over an extended period that results in a water shortage. Mega droughts are more severe and last for decades or longer. Droughts are actually a normal occurrence in nature, and the Southwest is used to fluctuations between wet and dry periods. Droughts can hurt the economic livelihood of farmers and ranchers, cause wildfires, and endanger wildlife that needs water to survive. They can also hamper electricity grids that rely on hydroelectric power. Governments across the US built reservoirs to control for droughts and floods. The most well-known megadrought in US history was the Dust Bowl of the 1930s. It plagued the plains of the central and southern United States, and the agricultural losses from that decade contributed to the Great Depression and the migration of millions of people to the West. But today, with higher than average temperatures, in large part due to human-induced global warming, and with increased population size and food demands, this era's megadrought could lead to even more severe outcomes. Scientists observing tree rings, which reveal historical rainfall levels, have determined that the West is now on the same trajectory as the worst prehistoric droughts. Between 2000 and 2020, every part of the Southwest experienced higher than average temperatures. That period was also the driest since the late 1500s, and the second driest since 800 CE. This heat and low level of precipitation is causing the Colorado River Basin, the main source of water for much of the West, to dry out. As a result, the largest reservoir in the country, Lake Mead, dipped to its lowest level ever in 2021. The future in the West will rely on water management and water conservation. Farmers will be hit the hardest since they use about 90% of the water in that part of the country. They will either have to change what they plant, stop growing for periods of time, or relocate to other regions. A drought of this proportion means water will likely need to be imported from further away regions, perhaps sparking future water wars.
And joining us now, Dr. Michael Mann, professor of atmospheric science at Penn State. Dr. Mann, thank you for the time.
Thank you. It's great to be with you.
Heat wave, droughts, what we've experienced so far this year, how does it compare to what we normally experience?
Well, I think we all sense that there's something different happening here. We're seeing heat waves out west that are unlike anything that we've seen before. The Pacific Northwest heat dome led to unprecedented record-breaking temperatures over a large part of the Pacific Northwest, the hottest temperature Canada has ever seen. The same summer where we saw the hottest temperature ever reliably recorded on the planet in Death Valley, California. And so, yes, we've always had extreme weather events in the past, but what we're now seeing is that these events, these heat waves and droughts and combine to give us these epic wildfires, flooding events, superstorms. These events are qualitatively different from what we've seen before, and what we're witnessing is the signal emerging from the noise. The signal of human-caused climate change is now big enough that we can literally see it in the form of these record-breaking extreme weather events that are playing out in real time this summer.
Let's focus on the Western fires. Is this just an endless year-long cycle now?
Well, unfortunately, in the very best case scenario, we're dealing with what many would call a new normal, which is to say there are now elevated levels of fire risk because of the heating and the drought and the way those have combined to give us a five-fold increase over the past half century in the aerial extent of wildfires in North America. These fires are burning over larger areas. They burn hotter, they spread faster, they do more damage, and unfortunately, they kill more people. And we know that that risk has already been greatly increased by human-caused warming. It's still within a range where we can likely adapt to this new state through appropriate land use policies and fire control policies. It's still at a manageable level. The problem is if we continue to allow the planet to warm up and these wildfires get bigger and more pervasive and do more damage, then pretty soon we're talking about a situation where we have to retreat from large parts of, the country that are now so fire prone that they're just not suitable for human habitation. That's the potential future that we face. In the best case scenario, it's a new normal. We stop burning carbon. We allow the warming of the planet to sort of level off, and we can deal with the impacts that have happened. On the other hand, if we fail to lower our carbon emissions, we continue to warm up the planet, then pretty soon we're going to start to, in essence, exceed our adaptive capacity as a civilization to these damaging extreme weather events.
If we do, in fact, manage it the way that you're laying out right now and the way that other scientists are laying this out, how long will it take to kind of reverse these cycles?
Well, the good news is that surface temperatures over the planet will stop increasing as soon as we stop adding carbon pollution to the atmosphere. And the latest climate model simulations, like those used in the most recent report of the Intergovernmental Panel on Climate Change, or IPCC, that just came out, those experiments show that we can stop the warming of the planet and the impacts that are associated with that. That's the good news. The bad news is that we are sort of elevated at this level of additional warmth, most likely for centuries. It would take many centuries, for example, to draw down the CO2, to actually take the carbon dioxide back out of the atmosphere, whereby those concentrations of carbon dioxide will slowly decrease and the warming eventually will start to come down. For all intents and purposes, we are dealing with elevated warmth and all of the risks that come with that for decades to come. And the real challenge now is to prevent the warming from continuing so that we keep the warming and all the impacts associated with it, again, within that sort of realm of adaptive capacity.
You mentioned that if this isn't managed, certainly some of these areas, people may have to retreat from them. Before that happens, though, I'm curious, could we get to a point where in certain areas of the country where people are living or planning to move, those areas become uninsurable? You can't get home insurance, for example, in some of those areas?
Yeah, as I've often said, uninsurability is sort of the first stage of uninhabitability. If you can't get insurance for your home because it's so risk prone due to elevated wildfire threats, and that's true in Western North America. It's true in large parts of Australia, where I spent a sabbatical a year and a half ago during what they called the Black Summer, when these bushfires blanketed the continent. It's true for our coastlines that are now subject to inundation by rising sea level, combined with more ferocious hurricanes and tropical storms. So there are these larger and larger regions where they are becoming so risk prone now to these extreme, weather disasters that have been exacerbated by climate change, that we're going to have a difficult time getting insurance for homes. And if you can't insure your home, then it's not safe to you and your family to live there. And so again, we're sort of going down this dangerous road of uninsurability in many of these regions and eventually uninhabitability. And we're talking about, a planet with finite space and food and water, a growing global population, and more competition for diminishing resources if we continue to allow climate change to proceed.
Dr. Michael Mann, professor of atmospheric science at Penn State. Dr. Mann, thank you so much for the time. We appreciate it. Next, a look at billion-dollar weather disasters in America and how they keep growing. As storms, fires, and extreme weather events become stronger, the cost to clean them up and rebuild after only becomes greater. The National Oceanic and Atmospheric Administration, NOAA, started tracking billion-dollar disasters in 1980. Since then, the U.S. has had 198 of them. In 1980, there were only 3 of these billion-dollar disasters, the biggest being a deadly storm that swept through the South, causing floods and leaving what amounts to almost $2.5 billion of damage in today's economy. There have been more billion-dollar disasters every year since then. Fast forward to the year 2002, where there were 6 different billion-dollar disasters. A drought that hit 30 states was the biggest. It stretched from the west through the Great Plains and all the way to the eastern U.S. Total price tag for the damage, $13 billion. Hurricane Sandy, that devastated a huge portion of the East Coast in 2012, caused $77 billion in damage. That's, of course, in today's dollars. And that's equal to the GDP, gross domestic product, of the entire nation of Guatemala in the year 2020. Coming up, we learn what factors lead to flooding and the importance of maintaining good water management in your city. From the Deep South to the Mountain West, floods have devastated communities across America. It's the most frequent natural disaster in the U.S. Ed Clark, director of the National Water Center, joins us now. Ed, thank you so much for the time. Let's start with the factors that increase severe flooding. What are those factors, Ed?
So causative flooding is really comes down to the driving event. Heavy rainfall, excessive rainfall, combined with the type of landscape in which it falls, contributes to flooding. I'll give you an example. 2019, in the Missouri Basin, portions of Nebraska, the ground was frozen. And so effectively you change a porous or a permeable surface into a cookie sheet, and you poured a bunch of water on top of that cookie sheet, and that contributed to one of the most devastating floods we've seen in the last 25, 30 years. So it really comes down to the rainfall, or the snowmelt event, plus the landscape in which it's falling, as well as the infrastructure that contributes or can mitigate the floods.
Ed, are there some areas of the states that are more susceptible to flooding than others?
So that's a tricky question. We see flooding in all 50 states across the nation. There are certainly portions of the country where we have built our environments to be more resilient to flooding, and there are steps that communities have taken across the country to be more resilient and more flood ready. That said, there are also portions of the country where we just see excessive rainfall happen periodically. So if you look at the more humid regions of the U.S., all of them can have these causative events, these severe rainfall events. We don't have to go back only a couple of years to look at Atlanta, to look at Nashville, to look at Nebraska, as I just referenced. It's really about where that rainfall sets up and how the riverine system responds.
When you say, Ed, severe rainfall, severe flooding, what exactly, is there a metric like over a certain amount that we're talking about here?
It's really rainfall that overwhelms the system. And so we the National Weather Service, and portions of my office, the Office of Water Prediction, produce the NOAA LS14, which is our precipitation estimates, our current reoccurrence interval estimates. We talk about this in terms of annual exceedance probabilities, in terms of a 100-year flood event or 500-year rainfall event. Those types of metrics do exist, and they're very much engineering-centric. They're used to design the infrastructure that conveys floodwaters. But in practicality, when we talk about severe events, it really is those systems that overwhelm the landscape's natural ability to convey floods away and safely move water through without exceeding those flood thresholds. That said, flooding is definitely a very local phenomena. It's a local effect. And so as we talk about the impacts of floods, they are very much locally based and derived from whether they impact infrastructure, transportation routes, lives and livelihoods.
Is severe flooding happening more frequently?
So that's a very tricky question. We are seeing a warmer atmosphere, right? As we continue down this pathway of a warming climate, we know that that a warmer air mass can hold more water. A warmer air mass with more water in it leads to higher precipitation rates or higher amounts of volume of water that can fall from the sky and cause floods. We are experiencing on the large scale an increase in some forms of flooding, the terms of the multi-week, multi-month floods. But flash flooding is very local, very localized phenomena. While we are seeing increased impacts, we aren't necessarily seeing an increased frequency. It's a very difficult question to answer, but what we say in the business is we want all people in this country to be flood aware, ready, resilient, responsive, and alert to the potential for flooding in their communities, and to know where to get the information. The National Weather Service, their local flood control district, their local municipality, where to get the information and what to do if they are facing floods in their communities.
Yeah, that's probably the most important part of this segment. The viewer, for them to be aware and prepared. What exactly does that mean, besides obviously knowing where to get proper info like the National Weather Service?
It comes down to this: know where to get the information, know your evacuation routes, know where your cherishable goods are. One of the things that tugs at my heartstrings is when we see a flood event that it's not the catastrophic flood, the flood that wipes out a home or destroys a community. It's a flood that wets the basement. It's a flood that destroys the cherishable memories, the photographs that folks may have. So know what to do, how to elevate the goods in your home to the right elevation so that they're away from floodwaters, and know what action to take to protect yourself and your loved ones, including your pets, when you are faced with a flood evacuation.
This year's hurricane season is off to an above average start. Next, what this could mean for future seasons. This year, tropical activity began before the official start of Atlantic hurricane season. And last year, we saw a record number of hurricanes. So what does this all mean? Tom Knutson, senior scientist with NOAA, joins us now to help us break all of this down. Tom, thank you so much for the time. Let's start with Atlantic hurricane season. When is the official hurricane season?
Well, it runs from June 1st through the end of November, roughly. But, the most active part of the season is the August, September, October, really.
Now, have you noticed anything about the start of the season lately? Perhaps it's starting earlier. And if so, I guess, why would that be?
Well, there have been some sort of preseason events in recent years, and that always raises some questions about whether the season length is changing or not. The science is still not really well established on that, because we have some issues with our records going back in time. It's really difficult to establish long-term trends, say century scale trends in the Atlantic Basin, because of these changes in technology over time. And that goes as well for changes in the season length.
As far as maybe areas that haven't been affected in the past by this hurricane season, but could be moving forward, is there any data on that as far as the area expanding here of places that could be impacted?
No, we don't have very much strong evidence on that. Our climate models that we use to try to make projections of hurricane activity under global warming scenarios don't really have much, don't really show much change in the locations of the activity. Instead, what we see are that the hurricanes can become slightly more intense with global warming, something like 5% over the next century. And the precipitation rates near hurricanes can become more intense. They do become more intense in these climate simulations. And that's something like 7% increase in rainfall rates per degree Celsius of global warming. And sea level rise is another really important effect of global warming. So these hurricanes, even if they don't change at all, they'll be riding in on a higher background sea level, causing more storm inundation than previously.
When you say that the intensity could increase 5% or 7%, help the viewer understand that. What exactly would that mean for a hurricane if it were to hit 5% stronger or the precipitation 7% more?
When we say a 5% increase of maximum surface wind speeds, that probably translates into a greater percentage increase in their destructive potential, because the destructive potential of these storms goes up as more than just in terms of the fractional change of wind speed. It goes up to something like the wind speed squared or the wind speed cubed. So it's really a nonlinear effect on the potential damaging effect of these storms. So a 5% increase in maximum surface wind speeds could mean something more like 15% increase or more in their destructive potential. We do expect with global warming, that the fraction of storms that reach these higher categories, like category 3, 4, and 5, we expect that fraction to increase as we have the shift toward higher intensities. And we think we're already seeing some evidence for that in the data.
Tom, last question, most important question. How should people prepare?
If you live in a hurricane-prone region, you have to realize that the possibility that these events can happen. The main message is be prepared when you're in a hurricane-prone region for the possibility of hurricane activity affecting your area. And of course, listen to the National Hurricane Center and your National Weather Service for advice on particular storms.
Tom Knudsen, Senior Scientist at NOAA. Tom, thank you so much for breaking down all of this very complex info for us. We appreciate it.
Hey, thanks for watching. If you like this video, check out these other videos from USA Today to stay up to date with all the latest news.